In lesson 2 and lesson 3, we're going to learn logarithms and logarithmic functions. So today, let's have a look at some introduction about logarithms. Today's learning goals. After today's lesson, you should be able to understand and interpret logarithms, understand and apply Power Law of Logarithms, understand and apply change of base formula, understand and apply product and quotient laws of logarithms, and understand logarithmic scales in physical sciences. All right, first of all, let's have a look at the interpretation of logarithms. Logarithms is denoted by this line here. Log b x equals y exactly if b raised to the y's power is x, and x is greater than 0 and b is greater than 0, and b is not 1. For example, log 264 is 6, as 2 raised to the power of 6 equals 64, right? So basically, the logarithm is just another expression of the exponential, right? For example, 2 raised to the power of 3 gives you 8, and this can also be written as log 8 with base 2 is 3. And we also know that 5 raised to the power of 2 gives us 25. This can also be written as log 5 25 is 2. And if r raised to the power of s is t, this can also be written as log r t equals s. Do you understand? All right, so let's make some practices. Rewrite each equation in logarithmic form. Okay, there are 3 expressions, both of them expressed in exponential form. And as we just said, logarithmic form is just another expression of the same thing. So I'll give you 3 minutes to think about these questions, okay? Okay, have we finished? So question A, if we express this in logarithmic form, we can write it as base 2 log 16 is 4, right? And next one, we can write it in the logarithmic form, base n e log m is 3, right? And next, we can write it in logarithmic form, base 3 log y9 is -2, okay? All right. Let's do another practice. Again, I'll give you 3 minutes to think about these questions, okay? Evaluate. What is the log 3, 81? What is log 2, 1/8? And what is log 10, 0.01? All right, let's have a look at these questions. Okay, question A. The log base 3 of 81, because you know that 81 is just 3 raised to the power of 4, right? So the log base 3 of 81 is 4. Next one, note that 1 over 8 is simply 2 raised to the power of minus 3, right? So the log base 2 of 1 over 8 is negative 3, right? So next, note that 0.01 is just base 10 raised to the power of minus 2, right? So log base 10 of 0.01 is negative 2, okay? All right, so let's do another practice. Rewrite in exponential form. A, log base 4 of 64 is 3. B, y equals log x. So I need to mention here, if there is no base number by default, the base number is 10. Right? So this is log x is actually log base 10 of x. All right, so I'll give you 5 minutes to think about these questions, considering using the definition of logarithms. All right, have I finished? Let's have a look at the solutions. Question A, because the base is 4 and the exponent is 3. In exponential form, the equation is just 4 raised to the power of 3 equals 64. Okay, next one. As I said, because there is no base written, this function is understood to be the common logarithm of x in exponential form, which has a base of 10, right? So this is 10 raised to the power of y equals x, okay? So as you can see here, the logarithm is just another expression of the exponential form, okay? Next, let's have a look at the power law of logarithms. Power law of logarithms states that the log base b of x raised to the power of n equals n times log base b of x, where b is greater than 0 and b is not 1. And of course, x is greater than 0, right? Because you have a log b here. And n can be any real numbers, okay? That basically states that when you have a x raised to the nth power, you can put the n here in front of the logarithm. Okay, we can prove this power law using the following method. First of all, we can let log base b of x equals y. Then according to the definition of logarithms, this can be rewritten as b raised to the y's power equals x, right? And we can raise both sides to the power of n, so that in that way we will have b raised to the power of yn equals x to the power of n, right? And if you rewrite this expression using logarithms, this is actually log base b of b raised to the y to the power of yn. This is actually log base b of x to the power of n, right? Which gives us log base b of x to the power of n is actually equals to ny, which is n times log base b of x, right? So in this way, we have proved the power law of logarithms. Okay, I'll give you 2 minutes to read this proof. You should be able to prove this power law of logarithms by yourself now. Okay. All right, so let's have a look at some questions. First of all, evaluate log base 5 square root of 125 using the power law of logarithms. Okay, I'll give you 3 minutes to think about this question. All right, have you finished? Okay, so note here, log base 5 of square root 125 is actually log base 5 raised to the 3/2, right? So this is actually 3/2 log 5, which is 3/2, right? The final result is 3/2. Okay, so using the power law of logarithms, we can just put the exponent in front of the logarithm, right? All right, so next let's have a look at another important formula, which is called the change of base formula. Change of base formula states that to calculate the logarithm with any base expressed in terms of common logarithms using the change of base formula, this can be written, this can be expressed as log base b of m equals log m over log b. Again, if there is no base number here, the base number is 10, where m is greater than 0, b is greater than 0, and b is not 1. Okay, so we can use the following method to prove this formula. First of all, we can let log base b of m equals x. Then, according to the definition of logarithms, this is just b raised to the power of x equals m, right? And we can find the logarithm of both sides using a logarithm base 10. So log base 10 bx equals log base 10 of m. And according to the power law of logarithms, you can put x in front. So x times log base 10b equals log base 10m, right? And we can solve x is actually log m over log b, which is x is actually log base b of m, right? So in this way, we have proved the change of base formula. Change of base formula is useful when you want to evaluate something like, for example, if you want to evaluate log 423, usually you cannot, it's very difficult to evaluate this mentally, right? So we can use a calculator, but in a calculator, normally you only can evaluate log base 10 of some number, right? If you have a calculator at hand, you can find a button like this. So let me show you an example. Okay, so this is a calculator in the Windows computer, right? So basically, you will have a similar interface in your calculators, and you'll find a log sign here. That means log base 10, right? So if you want to find log base 423, we cannot directly evaluate this using a calculator like this, right? So we can use a change of base formula. This is actually log base 10 23 over base 10 4, right? And then we can evaluate log 23 first, which is about 1.36. And then we can evaluate log 4, which is about 0.60. And then we can get approximate value of log base 4 of 23. Which is about 2.27, right? And also, if you use some advanced tools such as Google Sheets, we can also directly evaluate log base 4 of 23. For example, we can use a formula to evaluate. Okay, and use this formula. log 23 base 4, right? So as you can see here, the result is about 2.26, which is similar to the result of what we have in here, right? So you can choose either method. If you use a calculator, sometimes you will need to use a change of base formula, or you can use some more advanced tools such as Google Sheets to directly evaluate a logarithm such as log base 4 of 23, right? You can choose either method. Okay, and actually any logarithms can be rewritten in terms of logarithm with any base. So basically, log base b of x can be written as log base k of x over log base k of b for any x that is greater than 0. K is greater than 0 and b is greater than 0. Understand? So not only it works for base 10, but it also works for any base k as long as k is greater than 0. All right. Okay, so let's have a look at a practice. It is known that we can use a calculator to find that log base 10 17 is approximately 1.2304 and log base 10 5 is approximately 0.6990. Based on this information, let's evaluate log base 5 of 17. Okay, I'll give you 3 minutes to think about this question. Right, so let's have a look at the solutions. Actually, we can evaluate log base 5 of 17 using change of base formula, right? So this equals log base 10 of 17 over log base 10 of 5, right? So we have already given the information of log base 10 of 17, which is 1.2304. And log base 10 of 5 is 0.6990, right? So according to the change of base formula, we know that the final result is 1.839. Sorry, 1.760. All right. Okay, so let's take 10 minutes break, and after that, we'll continue our lessons for today. Okay, let's take 10 minutes break. Okay, so welcome back to the class. Let's continue our lessons. Okay, next, let's have a look at the product and quotient laws of logarithms. First, let's have a look at the product law of logarithms. Product law of logarithms states that log base b of the product of m and n equals log base b of m plus log base b of n for b greater than 0 and b is not 1. And m is greater than 0, n is greater than 0. Okay, we can use the following method to prove this product law. First of all, we can let log base b of m equals x, and we use a letter y to denote log base b of n, right? And then according to the definition of logarithms, this is actually can be expressed as b raised to the power of x equals m and b raised to the power of y equals n, right? So log base b of product mn is actually log base b of product of b to the power of x times b to the power of y, which is log base b of b to the power of the sum of x and y, right? So according to the definition of logarithms, this is actually x and x plus y. X plus y is actually log base b of m plus log base b of n, right? So in this way, we have proved that if you want to find the logarithm base b of mn, you can just use log base b of m plus log base b of n, right? And vice versa, right? Okay, as to the quotient law of logarithms, if we have already proved that product law of logarithms, we can prove it using the following method. The quotient between m and n is actually can be expressed as m times the reciprocal of n, right? Then according to the product law of logarithms, the left side is log base b of the product of m and the reciprocal of n, which is the sum of log base b of m and log base b of the reciprocal of n, right? And according to the power law of logarithms, we can just put the -1 in front, which is logarithm base b of m minus log base b of n, right? Which is exactly the right side. So quotient law of logarithms states that the logarithm base b of m over n can be written as log base b of m minus log base b of n. Understand? Okay, so please write these two formulas down onto your notebook because we're gonna use it to solve some problems. Okay, I'll give you 3 minutes to do this, okay? All right, so let's have a look at some practices. First of all, write as a single logarithms. Okay, I'll give you 5 minutes to think about this question. All right, so first, let's have a look at the solutions. So according to the product and quotient laws of logarithms, the first expression can be rewritten as log base 5, 6 by 8 over 16, right? This is log base 5 of 3. Second question, this can be written as log base 10 product of, okay, so first of all, these two terms can be canceled, right? So what's left there is log base 10 of x times three x, which is log 3x squared, right? But note here, the domain is x must be greater than 0 and y must also be 0, right? Pay attention to the domain here, because if you do not state this, if you do not specify the domain here, probably the domain in the new expression is different with the domain of the original expression, okay? All right, so let's have a look at some other questions. Evaluate the following expressions. I'll give you 5 minutes to think about these questions. All right, so let's have a look at these questions. First one, according to the product laws of logarithms, this can be rewritten as log base 8 of 4 by 16, which is log base 8 of 64, right? Because 8 raised to the power of 2 is 64, so the result is 2. And question B, this is actually log base 3 of 405 over 5, right? According to the Quotient Law of Logarithms. And this is log base 3 of 81. So note here, 3 raised to the power of 4 is 81. So log base 3 of 81 is 4, right? Okay, question 3. So note here, we can first use the Power Law of Logarithms to rewrite the original expressions as log base 10, 5 to the power of 2 plus log base 10 of 16 to the power of 1/2, which is log 25 plus log 4, which is log base 10, 25 by 4, which is log base 10 of 100. So note here, 10 raised to the power of 2 is 100. So log base 10 of 100 is 2. Okay. You can also check the complete solution on this lecture slides. All right, next, let's do another practice here. Simplify each of the following logarithms. Okay, I'll give you 5 minutes to think about this question. All right, so let's have a look at the solutions. First of all, log base 10 square root of x over x squared. This is log actually x raised to the power of 1/2 minus 2, right? Which is log x minus 3/2. According to the power law, we can put minus 3/2 in front, and this is actually log x, right? So note here x must be greater than 0 because it's under a square root sign here. And next, this is actually log x to the 3/2 times x to the power of 2, then over x to the power of 1/2. And this is log base 10 x 3/2 plus 2 minus 1/2, which is log base 10 of log of x cubed, which is 3 log base 10 of x. Also, x needs to be greater than 0, right? Next one, this is according to the quotient law, log base 10 twice of x minus 1 over x plus 1 times x minus 1, which is log 2 over x plus 1. So note here, first of all, 2x minus 2 must be greater than 0, right? Next, x squared minus 1 must be greater than 0, which means, first of all, x must be greater than 0, greater than 1, or x greater than 1, or x less than minus 1. So if we consider both of the conditions, the domain is x must be greater than 1, right? So we put the domain here. All right, so these are the solutions of these 3 questions. You can also check the complete solution in this lecture slides. All right. Okay, next let's have a look at logarithmic scales in the physical sciences. We'll use example questions here to illustrate this, this concept, okay? Okay, first of all, the pH scale. The pH scale is used to measure the acidity or alkalinity of a chemical solution. It is defined as pH equals to minus log the concentration of hydronium ions measured in moles per liter. And question A, tomato juice has a hydronium ion concentration of approximately 0.0001 moles per liters. What is its pH? And blood has a hydronium ion concentration about 4 times 10 to minus 7 moles per liter. Is blood acidity or alkalinity? See, orange juice has a pH of approximately 3. What is the concentration of hydronium ions in orange juice? 4. Question D, which has a greater concentration of hydronium ions, orange juice or tomato juice? And by how much? Okay, I'll leave you 5 minutes to think about this question, and we'll have a look at the solution together, okay? All right, so let's have a look at the solutions. First of all, to find the pH of tomato juice, substitute its hydronium ion and concentration into the equation. So its pH equals minus log H plus, which is minus log 0.0001, which is minus 4, which is 4. So the pH of tomato juice is 4, right? And using the same method, substitute hydrogen ion concentration of blood into the equation and use a scientific or graphing calculator to evaluate common logarithms. We can get the pH of blood is 6.4, which is below the natural value of 7.0. Therefore, blood is acidic. Question C, the pH of orange juice is given. To find its concentration of hydronium ions, rearrange the equation to express it in terms of the concentration of hydronium ions. pH is minus log H plus, which means minus pH is log H plus, right? So 10 minus pH equals the concentration of hydronium ions. So substitute the known pH and solve for the concentration of hydronium ions. We can get that the concentration of hydronium ions is actually 0.001, right? The unit is moles per liter. And question D, the pH and hydronium ion concentration in tomato juice and orange juice are summarized in this table. As you can see here, orange juice has a greater concentration of hydronium ions than tomato juice by a ratio of 10. Right? Okay, so let's have a look at another example. This is another example of how logarithms can be used in physical science. Okay, I'll give you 5 minutes to think about this question. All right, so let's have a look at the solution together. Question A, how many times as intense as a whisper in the sound of a normal conversation? Okay, so let's find what is a normal conversation. Normal conversation has a decibel scale of 60, right? Whisper is 30. So if we substitute these 60 and 30 into this equation, 60 minus 30 is 10 times log base 10 of I2 over I1, right? So that means I2 over I1 is actually 3. Sorry, log base 10 of log base 10 of I2 over I1 is 3. So that means I2 over I1 is 10 raised to the power of 3, right? Which is 1000. So the ratio of this intensity is 1000. Okay, question B. The sound level in the normal city traffic is approximately 85 decibel. Sound level while riding a snowmobile is about 32 times as intense. What is the sound level while riding a snowmobile in decibels? Okay, so again, if we put all these values in that equation, beta 2 minus 85 equals 10 times log base 10, 32 times, right? 32 times here. And then we can solve beta 2 is actually 85 plus 10 times base log base 10 of 32. And then we can find log base 10 of 32 using a calculator. This is approximately 1.5. So this is 85 plus 15, which is about 100. Right? Okay, and you can also check the complete solution in this lecture slides. All right, so let's make a summary of what we have learned for today. So now you should be able to understand and interpret logarithms and apply power law of logarithms, change of base formula, and product and quotient laws of logarithms, as well as understand logarithmic scales in the physical sciences. All right, so these are all the contents we have learned so far. And the rest of the time is reserved for you to complete today's homework, okay? Okay, you can start doing your homework for today.